Okay, I graded the quizzes from Friday. They weren't stellar by any means. But when I go back and look at homework grades and CK12 grades, when half of you don't do it, I guess I can't expect you to know what you're doing. And then also, I mean, I give you guys 3 chances on the big ideas. I could just change it back to 1. So it sounds like when I'm listening to everybody work in class, you're not really working on the problem. You're just rotating through who gets to guess ever many times, so that, you know, when one of you gets the right answer, then the other one can put the right answer in, and then it's your turn to guess the next one. And which, if you want to use the system that way, that's fine, but that's why your quiz grades are the way they are, because nobody really understood what they were doing. And I can tell you, I mean, just to give you a hint as you go through life, those of you who are going to college or going to finish up in high school, when you come to a teacher the week before the end of a quarter and you're failing, she doesn't have a lot of sympathy to help you out when you haven't given me any effort for the whole quarter. Okay, so if you choose to not do your work and you're okay failing geometry, I don't know what to do to help you. I mean, you don't do the homework, you don't do CK12 problems, and you wonder when you fail a quiz why you don't understand something. I don't know. I mean, you've got to put effort in math. You have to practice it, and you have to understand it. And if you guys don't understand something, call me over. That's why I'm in the class waiting to help you. Don't just try and then the homework is only worth 15% of your grade. So if you're going to work the system and take advantage of the 3 free passes I give you for that homework to get 15%, great, but you're going to have a 15% in the class then, because the rest of your grade is quizzes and tests. And if you're not understanding the homework, you're not going to pass quizzes and tests. I mean, does that make sense? Do you think you should be able to pass quiz and tests just because you got a 15% on homework by just trading answers? I mean, it doesn't seem like it makes sense to me, but I'm just telling you, my sympathy level is really low right now for this class. I'm not going to let you retake for full credit on this quiz. You're going to retake and you're going to get partial. I'll average the 2, whatever that is. When I pass those back, you can see them. I've still got a couple people that haven't taken it, so I can't let you keep it. But I'm disappointed in the effort. And I think at this point, my flipping method's not working. Okay, so we're going to go back, and I'm going to start talking and teaching you the whole period. And you can work on your web work or your classroom problems at home, because you're not taking advantage of me and having me in class now, so I'm not sure the point of trying to get you guys to come in. How many of you watched the stuff for today? So, I don't know. Whatever I'm doing isn't working because you guys aren't learning anything. So the method I'm using isn't working. And if you're not motivated to get grades just because you want some self-satisfaction of having good grades, I'm not sure how else to help you. I mean, I'm giving you lots of opportunities to ask me questions in class. None of you use that. You just work, you know, in your group and have one of you try a problem and the next one put the answer in, and you just keep going around until you get it right, which is 15% or of your grade as 100. Still not going to pass the class. I don't know. Am I wrong to be frustrated? You guys feel like you're putting more effort in than I'm giving you credit for? I'm not saying everybody. I know you've been doing the work. But I don't know. I've got 2, Xavier's in here, and then I've got Corey in first period, and he does it independently. And then I have 2 people in 7th period that typically work pretty well. But someone tell me the 5 ways we can prove 2 triangles are congruent. No. There's one. Yep.
Angle side, angle.
Okay.
Did you say angle side?
Yep. Side, side, side.
Angle side.
And then hypotenuse leg, which works with the right triangle. Hypotenuse leg, angle, angle, side, angle, side, 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 and angle, side, angle. Those are the 5 ways. And we've had them on homework. And yet when the quiz came and it asked, how do we prove these 2 triangles are congruent, I got definition of congruent triangles for answers. I mean, the whole purpose of those 2 sections, we're learning those 5 ways to prove triangles are congruent. So I don't know. But okay, So let's talk about 4-5. I'll probably spend a few minutes talking about it, and then I'm just going to do lots of example problems for you, and we'll just go all the way through until 12:30, and then you guys can do big ideas on your own. Okay? And CK12, both of those will be due tomorrow night. Get down to the bottom here, or the top. Okay. So here's kind of a review of what we might need to know coming in. So can everybody see that first triangle? If you want, you can pull your Chromebook up and look at the textbook for the first page so you can follow along. Now that I had you shut your computers. So give you a second to get those. Are they loading? So just go to section 4-5. While they're loading, I can tell you tomorrow I'm going to give you time in class to work on the chapter review for chapter 4. Wednesday, we're going to go through the review. Thursday will be your chapter 4 test. This is the last section of chapter 4. So, is it up yet for you guys? So that first triangle, what's the strategy you could use to find x?
All those together is nice equal 180.
Yeah, because the sum of the angles in a triangle equals 180. And if you know all the angles, which we know all the angles, they're just in terms of a variable x, all we have to do is add those three angles together and set it equal to 180 to solve. How about the second one? What could you do here? That second triangle. There's two strategies you could do. One's faster than another. What do you think? Not quite. Are all three angles equal? Okay, so if the two angles are equal, what kind of triangle is that? Isosceles triangle. So using that information, though, how could you find x? There's two ways. There's a long way and a short way. Anybody have an idea? What do you know about the two base angles? They're equal, and you know one of them is 3x minus 4, right? So what's the other? 3x minus 4. And now I know all three angles, right? I'm just going to add them all up and set it equal to 180 and solve. There really isn't a short way. That's about the only way I can think of. Okay. Next one. How could I figure out x in number 3? Yeah, those two sides are equal. What kind of triangle is it when two sides are equal? Isosceles. Yep, and those two triangles are equal, or two sides, sorry. So we would just say 8 equals x minus 3, or x minus 3 equals 8. Add 3 to both sides, x is 11. So both those side lengths are 11. Okay. Last question, if a triangle is equiangular, what's the measure of each angle? 60 degrees, right? If all angles are equal and they have to equal 3 or 180, then each angle must be 60. Okay. So isosceles triangle properties. An isosceles triangle is a triangle that has at least two congruent sides. So is an equilateral triangle isosceles? Yeah, technically it is, because an isosceles triangle has to have at least two sides that are equal. An equilateral triangle definitely has at least two sides equal. It has more than that. It has 3. So all equilateral triangles are isosceles, but not all isosceles triangles are equilateral. That makes sense? The next section, we learn how to construct an equilateral triangle. I'm going to move on to the based angles theorem. So the base angles theorem says if you have a triangle that's isosceles, meaning two sides are equal, the angle opposite both of those sides, so it really is technically this side goes to this angle, this side goes to this angle, those two base angles are congruent. And it goes the other way. If you know two base angles are congruent, you know their opposite sides are also congruent. Okay, isosceles triangle. Okay. I want to go on. Let's further. So in an isosceles triangle, if I take an altitude, which is just the line that comes down at a 90-degree angle, if these two are equal, that altitude bisects that vertex angle. The altitude, which means the line that comes down to the base at a 90-degree angle, bisects the vertex. This is the vertex angle. These angles are equal. These angles are equal with that altitude. Same is true on an equilateral triangle. All of the altitudes that come down will bisect those vertex angles. So if I tell you I've got an equilateral triangle, or sorry, let's make it an isosceles, and that this line is the angle bisector. This line is the angle bisector. Do I need a box drawn here to assume it's 90 degrees? Yes or no? If this is isosceles, and I tell you this is an angle bisector, meaning it bisects that vertex angle into two equal angles. Yeah, you can eventually prove that this is a 90, but it's one of the, well, it was just talked about in this section here. Any isosceles triangle, if that is an angle bisector, it's automatically a 90-degree when it comes down. Doesn't have to be written in. Okay? As long as you know it's an isosceles triangle and that's an angle bisector. Same is true if they tell you it's an altitude, meaning it comes down at a 90. You know those two angles are going to be equal because it's an isosceles triangle. It doesn't have to be given to you. Okay. And that's the isosceles triangle theorem. The angle bisector of the vertex angle in an isosceles triangle is also the perpendicular bisector to the base. So if you ever get into a proof where you have to prove those two angles are equal, this is the reason, the isosceles triangle theorem. So look at this example. Example 1. Which two angles are congruent? S and U. The angles opposite the sides. Example 2. If an isosceles triangle has base angles with measures 47, what's the measure of the vertex angle? You're going to say these are 94, so that must be 86. Yep. And example 3, to find this one, you would just take 2b plus 116 equals 180 and solve for b. Algebra connection. Let's go to, I don't want to slide anymore. The base angles theorem converse. If two angles in a triangle are congruent, then the opposite sides are also congruent. And then the isosceles triangle theorem converse, the perpendicular bisector of the base is also the angle bisector of the vertex angle. Okay, let's talk about equilateral triangles. If I could get to the top. Here's where it talks about every equilateral triangle is also an isosceles triangle. If we're told Like example 6, they're giving us an isosceles triangle and they want us to solve for x and y. So you could just start by setting the two sides equal, and once you know y, you can plug that in. So why don't we do a few sample problems? Volume 2.
So we're gonna bully you.
There is.
You guys already do bullying.
Okay, I'm just going to put some problems up. You guys want to get some paper out, you can close your computers now. Okay, close your computers. We're just going to do some sample problems now. If you need paper, you can get it out. Okay, what is x? 10. What's y? You good?
Yeah.
I'll wait for these two to come back. So they said that x was 10. You two agree? Jacob, you agree? X is what? It's an equilateral triangle. All sides are equal. So each side length is 10. So Sierra, what's y? What's y? Any idea how you could find y?
Sorry.
Okay, well, I'll give you another one then. Okay, give me an equation, Sierra, that we could use. What do we know about the 2 marks? What does that tell us? When 2 marks are on a triangle like that, what does that mean? Same length. Okay, so if they're equal, what's an equation I could write relating those 2 lengths? See, you did know. Okay, go ahead and solve that. Tell me what x is. Anybody get an answer? It's 14. Okay, so if x is 14, what is the length of one of those 2 sides? 14 plus 5, right? Okay, let me give you another one. Okay, the side length on the bottom is 3y plus 3. The angle on top is 2x plus 10. Start with x. How do we find x?
Well, it equals 60.
Good. The top angle equals 60. So what can I do?
That equation equals 60.
And then just solve. What about the bottom one?
How do you find the side?
Mm-hmm.
They're all the same, so there's 3y plus 3 times.
They're all the same. Actually, now that I look at it, sorry. That's that angle. Yeah, because there's nothing we could have used to find y. I was looking at that one and thought, I don't think you can find y. Yeah, if it's an angle now you can, right? What do you do?
So that equals.
Yeah, because all three angles have to be 60 in an equilateral triangle. Okay. Let's do another one. Find x and y. It says that EU is an angle bisector. So find x and y. This is EU. So what could I do to find x? Okay, 2x minus 1 equals x plus 2. And then solve, right? What do we know about this and this? Why? How do we know that? It's an angle bisector. So these two angles are equal. But how do we know that this is a bisector at the bottom? Well, if it comes down to the bottom, what is this angle at the bottom? 90. It's perpendicular, right? And what do I know about this leg as it relates to this triangle and this triangle? Is it the same measure? Yeah, that's the reflexive theorem, that it's equal to itself. Okay? So if I know this angle is a 90, and I know this is equal to itself, this is the hypotenuse leg theorem, which tells me these two triangles are congruent. And if they're congruent, this side is congruent to that side. That one is CPCTC. Once you prove the triangles are congruent, you use CPCTC to show that corresponding sides are congruent. Okay, so now I can go ahead and say 2y is equal to 16, y is equal to 8. Let's do a proof. Let's see here. I'll find a proof that I like. Can't spell isosceles. Okay. Base angles C and S. IO is angle bisector of CIS. Okay, here's the proof. We're given an isosceles triangle, and we're told that IO is the angle bisector of CIS. So we know this is true and this is true, and we know this is true, right? We're trying to prove that IO is the perpendicular bisector. Perpendicular bisector. What does that mean, perpendicular bisector? Yeah, so it's coming down at basically the midpoint of CS at a 90 degree. Okay, and in this proof, they actually give us, now that I've moved on, they give us just pieces to fill out instead of writing the whole proof on our own, which is nice. So number 1, they give us the reason. So what goes in is the statement. And IO is angle bisector, right? So I'm not going to rewrite that, but I'm just going to move that in. Okay. Number 2, they give us the reason. The reason is the base angles theorem. So what would I say as the statement if I'm using the base angles theorem as my reason? What's the base angles theorem? Yeah. Base angles theorem says in an isosceles triangle, the two base angles are equal. Can I just write C and S? Yeah, because I don't have more than one angle there at the vertex. Okay, so that's this. Right? Number 3, the reason is, nope, they give us the statement. Angle CIO is congruent to SIO. CIO is congruent to angle SIO. Why? Okay, what am I given? That IO is an angle bisector. So why could I say those two angles are equal? Definition of angle bisector. Definition of angle bisector. Okay, number 4. The reason is the reflexive property. Property of equality. Number 4, the reason is the reflexive property. So what would I say? Yeah, IO is equal to itself. Good. Number 5 says triangle CIO is congruent then to triangle SIO. So I've gone through and said these two base angles are equal. these two up top are equal and that this is equal to itself. So what theorem do I use to prove these two triangles are congruent? Anytime you have two triangles that are congruent, there's one of 5 theorems. We talked about them at the very beginning. Well, angle side angle would be great, other than they have to be consecutive. Means I didn't say that this length was equal to this length yet in my proof. The only thing I've said, let me erase that. Well, I only know one side. I have one side and 2 angles, but the angles are not consecutive in consecutive order. So tell me the 5 again. We don't know that this is 90 yet. That's what we're trying to prove. We have side, 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 but we only have one side, so that doesn't work. Side, angle, side, but we only have one side. We need 2 for side, angle, side. We have angle, side, angle, but remember, angle, side, angle, they have to be consecutive, right? Angle, angle, side. Angle, angle, side. So that's the reason here. What's that? We only know one side. The middle side. It's congruent to itself. Angle, angle, side. Does everybody see that there are 2 triangles here? Let me do it this way. Right? And I've proven that this is equal to this. And I've proven that this is equal to this. And I've proven that this is equal to itself.
I meant to say.
Oh. Okay.
And then I thought that you said
Okay. Angle, angle, side. Next one is that CO is congruent to OS. And I'm running out of room, so I'm going to go up here. This is number 6. Why? Why is CO congruent to OS? I've just proven the 2 triangles are congruent. What's the reason that this is congruent to this? Thank you. Nice. Because corresponding parts of congruent triangles are congruent. Good. And then number 7 says, this is blank, and it's again CPCTC. C. So what's something else that we haven't identified? Forget the sides. There's one other thing that's missing that we haven't said is equal because of CPCTC. What is it? Yeah. This angle COI is congruent to angle SOI because of CPCTC. The next statement says that these 2 angles are supplementary. Why? Why are these 2 angles supplementary? What's that? No, that only proves triangles are congruent. I'm saying that these 2 angles here, it's the definition of linear pair. Okay. Then the next one says the congruent supplements theorem. What does that mean? What's the congruent supplements theorem?
So these like anything. Supplementing supplementary.
Equals 180. So if the 2 angles are congruent, under the congruent supplements theorem, what do those 2 angles have to be equal to? 90. If 2 angles are congruent, right? They have to be 90. So these 2 angles are 90. I've just proven that. And I've proven that this side is equal to that side. So my last statement is going to be that IO is the perpendicular bisector because of the definition of perpendicular bisector. Okay? What's that? No. I have 3 more minutes to talk. It's hard to talk for a whole period. What's that? I know. Maybe starting chapter 5, I can go back to letting you guys work in class, but it'd be nice. You have a question on one of them? Okay. Why don't you ask me that in the last few minutes then? You have it? Okay. What's your question?
Find the values of x and y, and it's two triangles combined.
Let me just,
Two triangles split into one.
you want me to bring that up and I can draw it for everybody?
Thanks.
Actually, it doesn't give us that. Five y minus 4. Okay, so in this problem, where's the isosceles triangle? Is it the left one or the right one? It's actually both, but the one I'm working on is the left, right? Correct? Okay, so if these two are base angles, what are the two sides that must be congruent? The sides opposite the base angles, this one and this one. I didn't draw it very well. But those two must be congruent, right? And I'm told that this one is 3x minus 5, and I'm told that that one is y plus 12. So I could set those equal, but it's not going to help me yet. So what I need to do is do something with this. These are the angles, right? Is 5y minus 4,
Oh, so 5y minus 4 times 3 equals 180.
is it an angle that's 5y minus 4 is pointing to?
Oh, no, it's actually a line.
It's the side.
It's a side.
But we know that 3x minus 5 equals 5y minus 4, right? Because this is an equilateral triangle, right? All sides are equal. So I know 3x minus 5 equals 5y minus 4. So what does that tell me about these two? If this equals 3x minus 5 and this equals 3x minus 5, what do these two equal? Each other.
So we'll take all that.
So just set this equal to that. Solve for y. Once you know y, you can plug it back in here and solve for x. Right? If I told you that 4 equals y plus 12 and 4 equals 5y minus 4, these two are equal to each other, aren't they?
So y equals 4.
If I add there, subtract, I get 4y equals 16. Yep. So y is 4. And then plug 4 in here. 4 plus 12 is 16. 3x minus 5 equals 16. So 3x equals 21. X is 7.
Okay. That makes sense. Thanks.
Yep.